everyone, this is Mr. Fugay, and in this video we are going to talk today about matrix multiplication. So this process is a little more involved than scalar multiplication, which just involves multiplying or scaling up and scaling down a matrix. In this case, we're trying to take two completely different looking matrices, which we'll explain what situations warrant or don't warrant that in a few seconds, and you're multiplying with another matrix, and you're taking these two to combine them together to create a new unified matrix. Now there's a lot of different applications and reasons why this works, going from as simple as being able to take complex data and merge it together to higher up things involving computer science where we use these things called arrays, which are the name for matrices in that world. So this is just going to serve as a very basic introduction to kind of get you launched in that direction if that's something that you're interested in. So let's talk about it real quick. So just like adding and subtracting, we have to take a look at the size of the two matrices we want to multiply. The most important thing to remember is that the number of columns in the first matrix you're multiplying must be the same as the number of rows in the second matrix. Otherwise, this is going to be undefined. Now the other nice thing about this is the resulting row and columns of the new matrix, if this does indeed work, is that you're going to take the rows from A and the columns from B to create your matrix order, or that is your rows and columns. So an example here, we'll see that we have a 4x3 matrix on the left and a 3x1 matrix on the right. So as I mentioned, the center values, I guess I'll call them, which would be the columns of A and the rows of B, are the same, which means this matrix will multiply successfully together, and the order of the new matrix will have a row of 4 and a column of 1, as you see here. So the remainder of this video will now talk about how we actually get the answer, but the most important thing to start is before we begin any problem, you must check this. Here's an example of one that's not going to work, right? So in this situation, the columns of A and the rows of B do not match each other, and so we are not going to be able to successfully multiply these matrices together. And you'll see why in a few seconds when we go over a few examples. So let's go ahead and talk just about that. So once we've checked the number of columns and the rows, we can now multiply them together, but now this is the tricky part that you're going to have to listen to carefully. So this might be a part of the video you're going to have to pause and rewind and watch 1 or 2 times to get the gist, all right? So the main idea behind this is that if we have a 2x3 matrix and then a 3x2 matrix, in order to fill in the 4 cells that you see here, what we're going to have to do is take a combination of the row 1 of matrix A and column 1 of matrix B. Row 1, column 1 corresponds to row 1, column 1 of our final matrix that we're going to multiply together. So how do I figure out 1, 1 here, right? So we'll call this A11 in this example because we're trying to figure out this particular cell. Well, what I'm going to do is I'm going to take the row values of row 1, so 8, 1, and 2, and I'm going to pair them up with the column values of matrix 2. So in this case, the 8 would pair with the -5, the 1 would pair with the 0, and the 2 would pair with -11. We're going to find these values and we're going to multiply them together. So in this case, that's going to be -40 plus 0 plus -22. And so ultimately, this is going to end up being -62. So in fact, this is a little small for me for the video, so I'm actually just going to make it a bigger matrix just so you guys can see it better on your screens. So that means that the first cell, A11, is going to be a -62. Okay? Now, moving forward with this, I need to talk about, I'll switch to a pen now, I need to look at row 1, column 2. So row 1, column 2 will refer to A12, or that would be this particular cell right here. We're going to do the exact same thing. We're going to take the row elements of 8, 1, and 2, and we're going to pair them up with the column of B, which is 1, 2, and 7. And you're going to add these together. So same thing, you can put these in your calculator at this point. It doesn't really matter at this point, but I know that I'm going to get these values, which is going to give me a value of 24. So 24 is going to be A12. Okay, we're halfway there. So let's talk about how we're going to get the final 2 cells of this matrix. So now we're going to be looking at row number 2. So in row number 2, we're going to match that up with column number 1. So that's row 2, column 1. So that's row 2, column 1. So that is going to be the cell 2, 1. That's going to fill in this third spot down here. Just like we did with the first two examples, we're going to pair these up. So we're going to take the numbers -5, positive 6, and positive 7. Those are the row values. And then we're going to take the column values of -5, 0, and -11. And when I go ahead and multiply and crunch these numbers, I get a net value of, I believe, I'm not reading my handwriting properly, that's actually a -52. -52 is what I get for row 2, column 1. So -52, done. And then for the very last one, let's use a green pen this time. We're going to take row 2, column 2, and we're going to do the same exact thing and multiplying them together. So row 2 again had values of -5, positive 6, positive 7, and we're going to pair them up with the column values from matrix 2 of 1, 2, and 7. And just to confirm, this is going to be cell A22, which is what we're looking at in this bottom section. Adding these three values together and putting them in my calculator is going to give me a value of 56. And thus is the process. It took me about 5 minutes to explain, but we have our first matrix multiplication problem. Now, for the remainder of this video, I'm going to give you a chance to start trying some of these out yourself, but I'll also provide some instruction here as well. So the rest of this will be kind of a repeat now, but you'll be able to watch pieces and parts, and the more you need, the more I want you to watch through the last examples here. All right. So I'm going to do example 1 with you together, and if you want to try this yourself, you can pause and then either watch my explanation or fast forward through this. So the first thing I want to check here is the orders, just like we mentioned. The first matrix is a 2 by 2. The second matrix is also a 2 by 2. If we look here at the center values, again, these have to match. Oops, I can't get this to right. These have to match, and they do. And so the resulting matrix will have a row of 2 and a column of 2. So it's a 2 by 2 matrix. So let me go ahead and fill that in. And let's go ahead and walk through this process one more time. So the first thing I want to do to figure out A11, that would be the first cell, that would be row 1 of A, column 1 of B. So that multiplication for A11 is going to be 3 and -3, and then we're going to multiply it with 0 and -3 from column B. When I multiply those together, I get 0 plus 9. So my first cell here is going to be a 9. Continuing forward, let's use blue for this time. We're going to take row 1, column 2. So that's going to be A12. Row 1, column 2, that's going to be a 3 times -6. So that's the first of each piece. And then -3 times 4. We're going to put all that together, multiply that in my calculator, and we get an answer of -30. So this upper right cell, I should say, is going to be -30. We'll repeat the process now for row 2. So looking at row 2 in green, we're going to match that with column 1. So row 2, column 1. And when I multiply those out, I get -1 times 0. And I'm going to get 3 times -3. Again, I'm getting these from matching the values of the matrix up above here. That's where those numbers are coming from. And when I throw that on my calculator, I'm going to get an answer of -9. By the way, you don't have to put boxes around your answers like I'm doing here. That's actually not standard. I'm doing that to show you in color code how I'm filling in these rows. So ultimately at the end, I'll probably erase those boxes just because we're not actually supposed to write those. Last but not least, we got to take row 2, column 2. So that's going to be A22. That's going to be -1 times -6 plus 3 times 4. Multiply all those things together, and then we're going to get 18 as our final answer. And there it is. So for my final answer, let me go ahead and erase those boxes now, because technically we don't need those anymore. That was kind of like my training wheels. So overall, my matrix final answer is going to look like this. So at this point, for the remainder of the video, I would like you to press pause, and I would like you to try number 2, which you see right here. Move down here to try number 3. And lastly, try number 4. Press unpause when you've completed these, and I will have answers to all 3, and I'll do a brief overview of those 3 answers. All right, welcome back. And if you kept going here and or stopped immediately with number 2 and ran into a roadblock, that was supposed to happen. remember the first thing that we talked about in the beginning of this video. The columns of matrix A and the rows of matrix B, or in other words, I say the middle values, have to match. If they do not match, this matrix multiplication process that I just showed you in this video does not work. So number 2, it fails. But I have good news. If you want to press pause again, numbers 3 and 4 will work. So make sure you try those out if you haven't already done so, and I'll resume in just a few seconds. Alright, pause long enough. Let's go ahead and let's scroll to number 3. So I'm going to zoom out a little bit. Let me try to go full screen here so you guys can see it a little bit clearer on the video here. So you'll see there's a lot going on here, right? But what I ultimately did is I tried to color code this the best that I can so you could see how number 3 works, right? So for example, if I want this particular cell right here, that would be row 1, column 2. I'm going to go to row 1 of matrix A and column 2 of matrix B, and that's how I'm going to create what I have down here. So that's always a good way of also helping you learn this, is if you go with the cell that you want, you say to yourself, okay, this is row 1, column 1. You're always going to retrieve the row from the first matrix, and you're going to retrieve the column from the second matrix. And that's how you're always going to match these things up in order to find your answers. I'm going to scroll to number 4, but again, feel free to rewind and pause if you need to. For the very last example, and I believe I actually forgot to write my answer for the last cell here. So this should be 24. That actually should be an orange, but I don't have that pen out. So that corresponds to A22. Same thing as I mentioned. So if I look at this, let's walk through one of these, right? This is cell 1, 2. You're going to get that from the first matrix, and you're going to get that from the second matrix. So row 1 is 6, -5, -4. And column 2 in the second matrix is -2, -2, -6. And you'll see that those are exactly the numbers that I used down here to create my multiplications, threw them in my calculator, and got my cell value. As I said, compared to matrix addition, subtraction, and scalar multiplication, this is a significantly harder process. But if you follow the different steps that I've shown you in the last 10 minutes on this video, I do hope that this will give you some sense of process and understanding of this topic. I thank you for watching, and as I've mentioned, feel free to rewind, pause, go back to anything you missed in this video, and you can certainly ask me questions in class. Thanks for watching.